Hi, today we're looking at GCSE Maths. This is with the Pearson Edexcel exam board. We've got paper 2 from June 2023, and of course this is a calculator paper. Question 1. Write 6,184 correct to the nearest hundred. Right, well let's think, if it's hundreds, it's going to be between 6,100 and 6,200. To draw a quick number line. Well, halfway between those two would be 6,150. So 6,184 is going to be in this half. So we're going to round it to 6,200. Question 2. Write 0.7 as a fraction. So we can say, well, 0.7, the 7 is in the tenths position, so we can say that is just 7/10. Okay, but what you could also do is you could use your calculator for this one if you want to do a check, and we can type in the 0.7. I've got mine set to default to decimals. Yours will probably default to fractions if you haven't changed it. But you can press the SD button and it'll show us we've got it there, 7/10 as a fraction. Question 3. Change 9 meters into centimeters. Well, I know that 1 meter is 100 centimeters. So if we want 9 meters, well, we just need to multiply 100 by 9. Again, we can do that with a calculator. 100 times 9 to give us 900 centimeters. Question 4. Simplify 3 times 4t. Well, we can just multiply the numbers together. So I can use the calculator, 3 times 4. Now I'm just using the calculator because we can. Obviously it's great to do both. So use the calculator, but also check it with your mental maths. So 3 times 4 is the 12. The t is just multiplied by the 4. So now it's going to be multiplied by the 12 instead. Question 5. Here is a list of numbers. 20, 40, 60, 80, 100. One of these numbers is a multiple of 25. Which number? Right, well, you can try dividing them by 25, or you can do it the other way around. You can think of like 25 times table. So 125 is 25, 2 25s are 50, and again, you can use your calculator for this. 3 25s are 75, 4 25s are 100. Right, okay, so it's got to be that one. 100. Question 6. Shari has a fair ordinary dice. She rolls the dice once. On the probability scale, mark with a cross the probability that Shari gets the number 7. Well, an ordinary dice, you have 1, 2, 3, 4, 5 and 6. So probability of getting a 7 is 0 because there isn't a 7. On the probability scale, mark with a cross X the probability that Shari gets an even number. Okay, well if these are our 6 options, an even number could be the 2, the 4 or the 6, which would be 3 out of 6, which is the same as, and again this is where it's useful to use your calculator, 3 divided by 6 is 0.5. Press the SD button, we can see that's the same as 1/2. So doing the SD button, it will always, or even just typing it in, it will always simplify down to the lowest fraction. So 1/2 is going to be here. We put our cross. Question 7. Here is a triangle. The triangle is accurately drawn. That means we can use our ruler for this. So question A or part A, measure the length of AC. Well, AC is here to here. Now I'm going to measure it on here, and I'm getting, it's about 9.3 centimetres. Now in the actual exam, this would print out bigger, so you might find that the answer you get here is slightly different from the mark scheme, but that's not a problem. As long as you're measuring it accurately, you'll get what you need. Okay, and then for part B, measure the size of angle B. So for this one, I need to use my protractor. Now for some of you, if you're used to having your protractor this way up, then that's fine. You might find it helps to turn your paper upside down so that we've got the triangle the other way. But I'm going to do it this way. So I'm going to position my protractor here. So I've got the crosshairs on that corner because that's the angle we're interested in. Line it up here. And it's this angle that we want. So we're going to start with the 0, the outside numbers. So we're going 0, 10, 20, 30, 40, all the way up to where this line comes across up here. So we've got 100, this would be 105, and I think that's pretty much coming out at 106 degrees. They'll let you be 1 or 2 degrees away from the exact answer, but 106 looks good for me. Okay. Here is a different triangle, and we're told that QP equals QR. So QP, the line, and QR. They're the same. Write down the mathematical name of this triangle. Okay, well, if I've got a triangle, 2 of the sides are the same length, but the other one's different, well, that means it is an isosceles triangle. So 2 sides are the same, which also means that 2 angles would be the same as well. Question 8. The diagram shows 3 motorway service stations, P, Q and R on a map. We've got the distance between P and Q is 8 centimetres, well this is on the map, and between Q and R it's 16 centimetres. And we're told the map has a scale of 1 centimetre equals 4 kilometres. Work out the real distance from P to R. So we want to go from P all the way to R. Well, first of all, we're going to add our 8 plus 16 together, which gives us 24. Now that's in centimetres. Now we're told that 1 centimetre equals 4 kilometres. So if we want to get that in kilometres, we need to multiply it by 4. So I've still got the 24 in here from before, times 4, 96, which we can put on our answer line down here. Question 9. This is a 2-mark question. Here are the first 5 terms of a sequence. Write down the next term of this sequence. Okay, so we're looking at the pattern. So what we can do is, let's work out the difference between each of the numbers. So if we start here, let's do 8 minus 3. 5. So that means we're adding on 5 here. And what about between these two? 13 minus 8. It's still 5. And we're adding on 5 again. And 5 again. So if we want, the next term, so just 1, we're going to add on another 5. So 23 plus 5 gives us 28. And then for part B, write down the ratio of the second term to the fourth term. Give your ratio in its simplest form. So the second term, 1, 2, would be this one. And the fourth term, 1, 2, 3, 4, would be this one. So they want 8 to 18. Now we can look for common factors in these, but I'm going to use the calculator again. So we can say it's not exactly the same, but if we treat it the same just to simplify it, Well, let's say, well, what if we had 8 divided by 18? What would that simplify to if we do the SD button? 4/9. So this is the same as 4 to 9. In other words, we've divided both of these by 2. Question 10. This graph can be used to find the cost of parking a car in a car park for up to 12 hours. Use the graph to find the cost of parking a car for 4 hours. Okay, and let's move this up so we see that's for 1 mark. So 4 hours, find a number of hours, find a ruler, draw a line straight up, and then across. So that's going to be £6. Justin drives into the car park at 8 o'clock in the morning. When he drives out of the car park, he has to pay £9. At what time does Justin drive out of the car park? Okay, so he paid £9, so we can use our graph to work out how long he was there. So here's 8, here's 10, so 9 would be in the middle here. With the ruler again. You might think, oh, I don't need to use the ruler, I can see, but this is to show the examiner what you've done as well. So go across to here, and then read down. So that means they were there for 6 hours. So we've got 0800 or 8 o'clock. We're going to add on 6 hours. So 6 plus 8. And let's use the calculator because we can. 1400. If you want to change that into 2 o'clock, you can, but they haven't specified the format, so it would be fine like that. Question 11. The table shows information about the weights of the people in a hotel lift. Okay, so we've got 1 person weighed 40 kilograms, 2 people weighed 50 kilograms, and so on. Show that the total weight of the people in the lift is less than 1,200 kilograms. Okay, so we just want to add them all up, but we've got to think, well, we've got 250. So what I'm going to do is I'm going to multiply these all together. So the total weight of the 40 kilogram people, well, because there's 1, it's just going to be 40 kilograms. But we've got 250 kilogram people, so we want 50 times 2, which is going to be 100 kilograms. We've got 4 people weighing 60 kilograms, so 60 times 4, 240. 5 people weighing 70 kilograms, so 70 times 5, 350. 3 people weighing 80 kilograms, so 80 times 3, 240 kilograms. And 1 person weighing 90 kilograms. So let's add these all up. So 40 plus 100 plus 240 plus 350 plus 240 plus 90 gives us 1,060 kilograms, which is less than 1,200. And that was 3 marks, that question. Question 12. Shape A is reflected in a mirror line to give shape B. On the grid, draw the mirror line. So it's a bit like sort of lines of symmetry, but we're not actually going through the shape. So we're thinking, how is this reflected onto here? Well, it's going to have to be somewhere on this diagonal, because we want this point coming over here, this point's coming over here, This point's coming over here. So we're going to have a diagonal line. These 2 points need to be the same distance apart, so one box diagonally. Let's think, so this here, let's measure this one. We can do it in centimetres. So what's that? 7 centimetres, so halfway would be 3.5 centimetres. Should be somewhere about here. Can do the same thing up here. 7 centimetres, so again, going to be about here. So we can now connect these lines. There you go. Okay, and because they've drawn this nicely on square paper, it also makes sense that it's going to be going right through the corners of the squares as well. If you're not very comfortable with these questions, it will help if you've got like a small travel mirror or something as well to put it on the line, and you should be able to see, if I put it here, this reflected is going to be in exactly that position there. Part B. Alex is asked to reflect shape P in the x-axis. Here is the diagram Alex draws. Now the question down here, explain the mistake Alex has made. Well, it said reflect it in the x-axis. Well, this is the x-axis down here. So if he's reflecting it in the x-axis, that means that this is the mirror line. So instead of going that way, the shape should be reflected onto... They've not asked us to draw it, but I'm just going to put it on here so we can see. It should be something like that instead. Okay, so explain the mistake Alex has made. So he has reflected in the y-axis instead of the x-axis. Words to that effect. That's for 1 mark. Question 13. There are 50 teachers in a school. This is 1/16 of the total number of people in the school. Work out the total number of people in the school. Well, if this is 1/16, so 50 is 1/16. Well, another 50 would be 2/16. Another 50 for 3/16. So in other words, what we want is 50 times 16. Just to show that carries on. So 50 times 16 gives us 800. Question 14. Packets of sweets are put into boxes. So we've got, this is the size of the packet with the measurements, and these are the boxes here. Each packet is a cuboid, 80mm by 60mm by 20mm, as they've drawn on there. And each box is a cuboid, 72cm by 48cm by 24cm. What they put on there. Work out the greatest number of packets that can be put into each box. Okay, so at the moment we've got different units. Millimetres, centimetres. Let's turn them all into the same units. I know there's 10mm in 1 centimetre, so I'm going to change my centimetres into millimetres. The reason I'm doing that is because if I go the other way, then actually we can do the other way. Does it matter? Yeah, no, it probably makes more sense to do that, to be honest. Let's change the millimetres into centimetres. So we're going to divide by 10. Divide this by 10. Divide this by 10. When we divide it by 10, we just take a 0 off. So that's going to be 2 centimetres. And this would be 6 centimetres. And this would be 8 centimetres. So just to make that clearer, I'll draw another little sketch over here of the packet. So we're now saying that we've got 8 centimetres by 6 centimetres by 2 centimetres. Right, so we wanted to work out the greatest number of these packets that will fit in this box here. So I'm going to look at each dimension separately. So I'm saying, well, going along this way, if that's 72 centimetres, how many of these could we fit going that way? So we want 72 divided by 8. And 72 divided by 8. Oh, is 9. Okay. Now, if we think in this direction, this dimension here, so 48, these are 6 centimetres for the packet, so we want 48 divided by 6. So we could get 8 going that way. So if you think we've got like 1, 2, so we're splitting them up this way, and we're splitting them up this way. And then what about the height? So we've got 24 centimetres up here. If each of them are 2 centimetres, we want to do 24 divided by 2, which gives us 12 packets. So we've got, so actually let's draw another little sketch. Yeah, not wonderful, but that'll do. So we're saying we could get 9 packets along this way. We can get 8 packets along this way and 12 packets along going up. So if we want to know the total number of packets, think of it like volume. We're just going to multiply them all together. So we want 9 times 8 times 12. Which gives us 864 packets. And that was worth 4 marks. Question 15. Here is a fair ordinary dice and a fair 8-sided spinner. Here's a dice, here's a spinner. Charlie throws the dice once and spins the spinner once. Is Charlie more likely to get a number less than 3 on the dice or a number greater than 5 on the spinner? Well, on the dice, and remember we've got 1, 2, 3, 4, 5 and 6 as our options on the dice. Even though it's only showing 3 sides, we have got, these other sides at the back. It's 3-dimensional. So a number less than 3 would be just 1 or 2. So it would be 2 out of 6. Now a number greater than 5 on the spinner, well, it would be 1. It would be the 6, the 7 or the 8. So it would be 3 out of 8. So we want to know which one is bigger, so more likely, it's a bigger probability. So all we've got to do is turn these fractions into decimals. 2 divided by 6 is 0.333, and 3 divided by 8 is 0.375. Hopefully you can compare these and see, well, this one is bigger. What might make it easier for you, if you want to multiply by 100 and turn them into percentages, then you'll see we've got 37.5%. And if we did the same with this one, we get 33.3%. So that makes it a little bit easier to see it's the second one. Question 16. Paolo drives at an average speed of 56 kilometers an hour for 1 hour 45 minutes. Work out the distance Paolo drives. So in the first hour, he's going to drive 56 kilometers. And for the 45 minutes, well, it's going to be 45 minutes out of 60 minutes for an hour. So 45 divided by 60. So that's 0.75, or we could think of it as 3/4 of an hour. Okay. So we want 3/4 of an hour, multiply that by 56 miles an hour, so it's going to be 42 kilometres. So that's for the first hour, and that's for the 45 minutes. And if we add these together, well, actually, we can go straight down to the answer line. 42 plus 56 is 98 kilometres. If you wanted, you could say 1 hour 45 minutes is the same as 1.75 or 1 3/4 hours, and then multiply that directly by the 56. So that's just an alternative way of doing it. But I think it makes sense to do it this way. Split it up, it's easy to see what you're doing. Question 17. There are 3 cinemas, A, B and C. The mean number of seats per cinema is 380. So that's across all 3 of them. There are 350 seats in cinema A. There are 250 seats in cinema B. Work out the number of seats in cinema C. Well, the way we work out the mean is by working out the total and dividing by the frequency. Well, with this, we know what the mean is because they've told us the mean is 380. We don't know the total, but we do know the frequency because it's 3 cinemas. So what we can do is we can move this across and say, well, the total number of seats, and I'll put total seats, is going to be 380 times 3, which is 1,140. Well, we know there's 350 in cinema A, so we can take that off. And we know there's 250 in cinema B. So if we subtract both of those, so take away 350 and take away 250, we're left with 540. And that's how many we must have in cinema C. So it's the biggest cinema. And we can put that down here. And you'll see we've got 4 marks for that question there. Question 18. Asher buys 180 cans of cola. The cans are sold in packs. There are 12 cans in each pack. Each pack costs £3. Work out the total cost of the cola Asher buys. Right, 180 cans and 12 cans in a pack. So if we do 180 divided by 12, this will tell us how many packs she buys. So that's 15 packs. And if they're £3 a pack, multiply that by 3, and we get £45. Now for part B, just move it up so we can see the 3 marks for part B. So Ethan buys a box of 24 cans of lemonade for £7. There are 330 millilitres of lemonade in each can. Work out the cost of 100 millilitres of lemonade. Well, give your answer correct to the nearest penny. So let's work out how much lemonade we've got in total. So we've got 24 cans, each with 330 millilitres. So 24 times 330 means we've got 7,920 millilitres. Okay. And we know that that cost £7. And we can think of £7 is 700p. So what I'm going to do is say, well, how much would it cost for 1 milliliter? So that would be 700 divided by 7,920. Okay, 700 divided by 7,920. So a very small amount. But we want to know how much it is for 100 milliliters, so we're then going to multiply that by 100, which gives us 8.8383 blah blah blah, and that's pence. They said to the nearest penny, so these are our pennies or pence. Look at the first digit afterwards. It's an 8, it's 5 or more, so we're going to round that up to 9p. Okay. That works absolutely fine that way. If you want an alternative, which you might find more straightforward, you can take the money. So we can say, well, it's £7. Again, think of it as 700p. Divide it by 24 to find out how much it is for 1 can. That gives you, was it 29.16666, and that's pence. And then we can do something similar. We can divide that by 330 and then multiply it by 100. We still get the same answer, 8.8 something to 9p, but you might find it easier because you've just got slightly smaller numbers. Either way, we get our answer of 9p. Question 19. 240 people work at a factory. Of these, 150 have a car, 110 have a bicycle, 65 of the people who have a bicycle do not have a car. Use this information to complete the frequency tree. So let's move this up so we can get the frequency tree in there. Yeah, that's it. We can chop off the 240 because we've got it here. So 150 people have a car. We'll put that in there. So this number must be the difference between them. So we've got 240 in total. 150 have a car, which means 90 people do not have a car. 110 people have a bicycle. But it could be people with a car and a bike, or without a car and a bike. So we can't really use this 110 just yet. We know that these two need to add up to 110. 65 of the people who have a bicycle do not have a car. So of this 110, 65 of them don't have a car. So that means this must be our 65. So this, the ones with a bike and with a car, must be the 110 minus 65, which is 45. Now to find the people who have a car but don't have a bicycle, it's going to be this 150 minus the 45. So in other words, these two are going to have to add up to this one, in the same way that these two have to add up to that. So we want the people who do not have a car and do not have a bike. Well, it's going to be 90 minus 65, which gives us 25. And that was for 3 marks. And then for another 2 marks, what percentage of the 150 people who have a car also have a bicycle? So we're talking about the people who have a car, so it's going to be out of 150. We want the ones who also have a bike. So that's going to be 60. Of the people who have a car, so it's these ones who also have a bike. So it's going to be 45 out of 150. They want it as a percentage, so we're going to multiply that by 100. So 45 divided by, so hopefully you can see this, 150 multiplied by 100 gives us 30%. Okay, question 20, part A. Work out the value of 25 minus the square root of 43.87, all divided by 6 plus 2.1 squared. Write down all the figures on your calculator display. Right, so it's up to you how you want to do this. You can try and type the whole thing in. Let's see, we could certainly do the top. What's good to think about when you're doing this is because we've got a divide sign, although they're not there, it's like we're saying that's in brackets and that's in brackets, because we're having to do all of the top separately and all the bottom separately. So if you were to type it all into your calculator in one go, then you'd probably need to use brackets to split it up like that. Let's see, I'm going to just type in the top part first and see what answer I get to help me decide the best way to show it. So 25 minus the square root of 43.87. Okay, so that's going to be the top. 7, 6, 5, 5, 6, 7, 9. I'm just doing it like this for now. And in fact, what I can do is I can now say divided by, so I've done the top. Now for the bottom, I'm using my brackets and I'm going to say 6 plus 2.1 squared, close brackets. So I've worked out the top and I'm dividing by all of the bottom in one go there, which gives me 1.76527923. Okay, so you might want to do it a different way. So you might want to put it all in your calculator. I just feel a bit more comfortable doing a bit at a time so I can kind of see where I'm going. If part B, work out the value of the reciprocal of 0.625. The reciprocal just means 1 divided by it. So 1 divided by 0.625 is 1.6. Write down 60 as a product of its prime factors. Right, 60. So let's pick any two factors that multiply together to give 60, not including 1 and itself, because that won't make it any smaller. Well, I know that 2 is a factor of it, because it's an even number. So let's see, what's 60 divided by 2? 30. Okay. Well, 2 is a prime number, so I'm going to stop there. But 30, well, I can see I've got 3 is going to go into 30. And how many times does 3 go into 30? 10 times. 3 is a prime number, so I can stop there. What about 10? Well, I know 10 we can divide by 2. So we can split that into 2 and 5. And they're both prime numbers, so we're going to stop there. So if we want this as a product of its prime factors, we can say that 60 equals, well, we've got 2. It's always best to write them from smallest to largest. So 2 times 2 times 3 times 5. And if you want to check that, 2 times 2 times 3 times 5 gives you 60. If you want to write this as 2 squared times 3 times 5, that's absolutely fine. Either way is all right. That's equals. Question 22. There are 48 counters in a bag. There are only red counters and blue counters in the bag. The number of red counters to the number of blue counters is 1 to 2. Helen has to work out how many red counters are in the bag. She says there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Is Helen correct? No, she's not. I mean, one way to see it quickly is, well, 24 is half of 48, so that means if there's 24 red counters, there must also be 24 blue counters. But that doesn't make sense because we're told that there's more blue counters than red counters. So she's definitely wrong. Another way of showing it is if we draw a little ratio table. Red counters, blue counters, total. We've got a ratio of 1 to 2. If that's all we had, there'd be 3 in total. We've actually got 48 in total. So we want to see how many times this top row we've got in the bottom row. So we can do 48 divided by 3, 16. So we've got 16 red ones. And if we do the same to the blues, oh, didn't mean to do that, 2 times 16. So we've actually got 16 reds and 32 blues, because we've got twice as many blues as reds, and we can check because 16 plus 32 equals 48. So that's going to be useful because we could write, is Helen correct? So we can say, no, I say we can put reds are 16, not 24. Something like that. You can write it in lots of different ways. If you've got the numbers here to help, that definitely makes it easier. Question 23. Minus 2 is less than or equal to n, which is less than 5. N is an integer. Write down the greatest possible value of n. Well, n is less than 5. Integer means whole number. So what's the biggest whole number that's less than 5? Well, it's 4. Part B. On the number line below, show the inequality minus 4 is less than or equal to m, which is less than 1. So for these inequalities, especially when we've got a value at either end, we can draw our circles on. So minus 4, we can have a circle here. And at 1, we're going to have a circle here. Now, I keep the circles not drawn in or coloured in to start with, and then we'll decide if we need to. So we've started to draw the inequality. So minus 4 is less than or equal to, so it can be this number, which means we can colour that one in. But at this end, it's less than 1, so it can't be 1 as well, so we have to leave it not coloured in there. Now for part C, and this is a 3-mark question. 2/5 of g minus 4 is less than 6. And it wants us to solve it. So the fact that it's an inequality, a less than, doesn't matter. Treat it as if it was an equals and solve it the same way. So we want to get the g on its own. So the first thing we're going to do is to move this minus 4 over here. So it's going to become a plus 4. So we'll have 2/5 of g. The less than stays there. And we've now got 6. Because we moved the minus 4 across, it becomes a plus. So we've got 6 plus 4, which is 10. I'm going to do it one step at a time. So we're dividing by 5 at the moment. So we move it across. It's going to become multiplied by 5. So we've still got the 2g. 10 times 5 becomes 50. Okay, now we want to get rid of the 2. So to get rid of the 2, we're going to divide by 2. Move it across, that's becoming divide by 2. So we get that g is less than 50 divided by 2, which is 25. We can put that on our answer line down here. Question 24. Here is a triangle and a rectangle. All measurements are in centimetres. The area of the triangle is 10 centimetres squared greater than the area of the rectangle. Work out the value of x. Right, so we know the area of a triangle is half times the base times the height. So it's going to be a half times 8 times 6x. Well, let's deal with the number bits first of all. So a half, well, we can put that in as 0.5 times 8 times 6 is 24x. And then let's work out the area of the rectangle. Well, the area of the rectangle is just the length times the width. So the area here is going to be 5 times, we've got to keep this in brackets for now, times 4x minus 1. So if we want to expand the brackets, we'll do 5 times 4. So 20x. So we multiply the 5 by this and the 5 by the minus 1. So 5 times minus 1 is going to be minus 5. Right, so we can use this to make a little equation now. So the area of the triangle is 10 centimetres greater than the area of the rectangle. So 24x is the area of the rectangle, but this is greater by 10, so we need to add on 10 to the rectangle. So now we just got to solve it. So 24x, we'll keep this here for now. 20x, so all I'm doing in this step is combining my minus 5 plus 10. So minus 5 plus 10 gives me 5. Now I want to put my x's together. So I'm going to move this across. So I'm going to be making that a minus 20x. So 24 minus 20 is going to leave me with 4x. And all we've got left over here now is the 5. So 1x, well, now I'm going to need to get rid of that 4. I'm going to need to divide by the 4. So it's just going to be 5 over 4, or 1.25 centimetres. And that was a 4-mark question. And we do need to put, well, actually we don't need, I would put the units in there just to be safe, but they do say all measurements are in centimetres, so you shouldn't lose a mark if you didn't put it, but it's always best to include the units. Question 25. Last year a family recycled 800 kilograms of household waste. 57% of this waste was paper and glass. The ratio of the weight of paper recycled to the weight of glass recycled is 12:7. Calculate the weight of glass the family recycled. Okay, so let's work out how much of this waste was paper and glass first of all. So 57%, or 57 out of 100, of times 800. Move this on this side. So 57 divided by 100 times 800, 456. So we've got 456 kilograms of waste was paper and glass. Now we can start looking at the ratio. So we'll draw a little ratio table here. So we've got the ratio of paper to glass. We're going to have a total. The ratio is 12 paper to 7 glass. So for every 12 kilograms of paper recycled, 7 kilograms of glass are recycled. And if we just had the 12 and the 7, we'd have a total of 19 kilograms. But in fact, we haven't got 19 kilograms. We know we've got 456 kilograms. So we've got to work out how much bigger, or how many times bigger is this. So we can do 456 divided by 19. And that gives us 24. So we're multiplying everything on the top row by 24 to get our new row down here. So that's going to be times 24. That'll be times 24. So 24 times 12 means they recycle 288 kilograms of paper and 168 kilograms of glass. And it's always good to do this check. If we do 168 plus 288, it should give us this. Good. Now the actual question was just asking about the weight of the glass. So it's going to be 168 kilograms. But I think it's worth doing all of the numbers because that way you can just make sure it all adds up. Question 26. A number D is rounded to 1 decimal place. The result is 12.7. Complete the error interval for D. So the error interval means, well, what's the smallest number D could be? And what's the biggest number D could be? So if it's been rounded to 12.7, it could have been less. How much less? Well, it could have been 12.65. Because the 5 means we'd round up to 12.7. Anything less than this, so 12.64 for example, you'd round it down to 12.6, so you wouldn't get this answer. So for the top end, well, what's the biggest number? So what, it could be bigger than 12.7, but then rounded down to 12.7. Well, 12.73 would round down, 12.74 would round down, 12.75, because of the 5, you'd round it up. But this is a less than sign. It's not less than or equal to. So everything less than 12.75, so in other words, 12.749999 would still round to D. So this is the error interval thereafter. Question 27. This is for 4 marks. Tamsin buys a house with a value of £150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000. The value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. Okay, let's start with Tamsin. So we've got £150,000 and increasing by 4% each year. So what we'll do is we'll say, well, it's going to be the original 100% plus 4%, or in other words, 104%. Now, if we want that as a decimal, we divide it by 100, which is 1.04. So if we want to increase £150,000, oh, I've missed out a zero, sorry, £150,000 by 104%, we're going to multiply it by 1.04. And because it's for 2 years, multiply it by 1.04 again. Or you can think of it as 1.04 squared. If you'd like to use a formula, you'd do it as 1.04 squared. But I think doing it this way shows us we've got the original amount. By multiplying it by 1.04, we're working out 104% of it. So that would be the value after 1 year. Multiply by 1.04 again, we get 104% of that value, which means we've got the total value at the end of 2 years. So 150,000 times 1.04, and say if you want, you can make that squared instead of typing it in twice. And we get £162,240. Now, for Rachel, her house was more to start with, £160,000, but it's increasing in value by a smaller amount. So again, we've got 100%, and we're adding on 1.5%, which is going to be 101.5%. So if we divide that by 100, we get 1.015. So that's 101.5 or 101% as a decimal. So we're going to need to multiply that by 1.015. That's for the first year, and then do it again for the second year. So 160,000 times 1.015 squared, because we're multiplying it twice, and we get 164,836. And it said, at the end of the 2 years, whose house has the greater value? Well, it's Rachel. And the last question, we've got question 28. Here are 5 graphs. Okay, and we've got down below, the table shows the equations of these graphs. Match the letter of each graph with its equation. Right. Well, I'm going to start with the easiest ones, I think, which for me are the straight lines. Because we should all know that the equation of a straight line is y equals mx plus c. So we want something that looks like this. Now, the only real or big difference between these two is the fact that this is sloping down, this is sloping up. So sloping up means that this should be a positive gradient, and sloping down should be a negative gradient. So let's see if we've got equations that look like those. Well, these two look to be straight lines because they've just got x. They haven't got an x to a different power, squared, cubed, or 1 over. So it's one of these two. And remember we said if it's sloping up, it should have a positive gradient, so a positive x. And this has got a negative gradient, so sloping down. So which was the one sloping up? So D's sloping up. So that would be this one here. And this one's sloping down. So that's going to be A. Right, so we've got 3 to choose from now. So which one should we go next? Well, I think the x squared one is probably going to be the next most straightforward one, because I know if you've got x squared, you expect a curve either like that or like that. Well, we've only got one graph with anything like that, and it's B. Okay, so now it's between the last two. With my x squared, I knew that it was going to be a shape like this, because if it's squared, it means that the graph is changing direction once. Once there, or once there. With x not squared, it doesn't change direction at all, because it's a straight line. When it's an x cubed, it means it's going to be changing direction twice. And the only graph that is doing that is this one here. It's going down and then back up again. So E is going to be my x cubed minus 2, which means that y must be this one here. So that's graph C. Okay. If you don't know these ones or are less comfortable, it'd be good to go online, find a sort of a graphing app where you can type these in and get used to seeing some of the different shapes and what would produce different pictures. If not, do it as a process of elimination like this. Okay, so that's the end of the paper. That was worth 3 marks, that question. Please like the video, subscribe to the channel, turn the notifications on so you find out when I add more videos, and I look forward to seeing you again soon. Thank you.